You wouldn't last 3 nights in a Viking winter shelter. Not because of the cold, because you'd build it wrong. Modern humans think shelter means walls and a roof. Vikings' new shelter meant managing moisture, ground cold, and air movement simultaneously. Get one wrong, and hypothermia starts while you sleep. Most people would wake up weaker each morning until they didn't wake up at all. This is not about longhouses from museum diagrams. This is not about the aesthetic of turf roofs or the romance of communal fires. This is about construction methods developed by people who understood a simple equation. Bad shelter equals death within days. And there was no hard store, no rescue team, no backup plan. Vikings didn't build homes for comfort. They built thermal management systems using materials that would be considered garbage today. Every structural choice served a physiological function. The shape of the roof controlled smoke flow and heat retention. The thickness of walls determined moisture regulation. The placement of the fire dictated survival radius during the darkest months. This video examines one thing: how Vikings constructed functional shelter with minimal resources in an environment that killed efficiently. No mythology, no warrior culture, just engineering born from environmental pressure. If you think survival is about toughness, you're already thinking wrong. It's about understanding heat loss, moisture dynamics, and material properties. The Vikings didn't survive because they were stronger. They survived because they built better. Northern Scandinavia wasn't just cold. It was wet, dark, and windy simultaneously. Ground temperatures stayed below freezing for months. Precipitation came as snow, sleet, and freezing rain. Wind chill accelerated heat loss from any exposed surface. Timber was available but limited in quality. Most trees were stunted, twisted, or too small for large beams. Stone was abundant but difficult to work without metal tools. The ground froze solid, making excavation nearly impossible during winter months. Daylight disappeared for extended periods. Construction had to happen during short summer windows, when the ground thawed and materials could be gathered. This meant building had to be fast and couldn't rely on complex techniques or specialized tools. The primary threats weren't obvious. Ground cold pulled heat from the body faster than air temperature. Moisture from breath, cooking, and wet clothing created condensation that destroyed insulation. Wind penetration through small gaps created convective heat loss that no fire could compensate for. Resources were scarce. Iron for tools was expensive. Rope required animal sinew or plant fibers that took time to process. Even basic materials like clay for chinking had to be dug, processed, and applied during narrow weather windows. The environment set hard constraints. Build with what's immediately available. Finish before winter. Make it maintainable without specialized knowledge. And ensure it can be heated with minimal fuel. Failure in any category meant gradual energy depletion until the occupants couldn't maintain body temperature during sleep. The shelter wasn't competing with modern standards. It was competing with death by exposure. The human body loses heat in 5 ways: radiation, conduction, convection, evaporation, and respiration. In a cold environment, all 5 accelerate simultaneously. Modern humans are particularly vulnerable because we've eliminated the need to consciously manage any of them. We don't understand ground cold. Lying on frozen earth pulls heat from the body at a rate that overwhelms metabolic heat production. A modern person sleeping on cold ground in a sleeping bag will lose core temperature faster than someone sleeping upright in cold air. The contact surface area determines heat loss rate, and we've forgotten this matters. We don't manage moisture. Breathing in a sealed space creates humidity. Humidity condenses on cold surfaces. Condensation soaks insulation. Wet insulation loses thermal resistance. This cycle compounds until the shelter becomes colder inside than outside. Modern humans seal buildings and add mechanical ventilation. Remove that system, and we don't know how to design airflow manually. We don't regulate fire correctly. We think bigger fire equals more heat. Vikings' new fire placement, size, and fuel type determined whether heat stayed in the shelter or escaped through the roof. Modern heating is thermostatic. We set temperature and forget it. Ask someone to maintain 15 degrees Celsius in a stone structure using only wood, and they'll either freeze or waste fuel. We've lost material intuition. We don't know which materials insulate, which conduct heat, which handle moisture, or which fail when wet. Vikings could assess a piece of turf and know it's our value instinctively. They understood that different woods burned at different rates, and that stone placement affected draft patterns. Most critically, we don't understand the difference between comfort and survival. Comfort means 20 degrees Celsius, and no drafts. Survival means staying above 10 degrees Celsius core temperature while sleeping. Vikings built for survival. Modern humans would build for comfort, waste energy, and run out of fuel midwinter. The gap isn't knowledge, it's systems thinking. Vikings saw shelter as a thermal regulation machine with interdependent parts. We see it as walls, roof, and heat source. That cognitive difference is why a modern human, with all the same materials, would still build a death trap. Shelter failure happens through three mechanisms: ground cold conduction, moisture accumulation, and heat escape. You can have walls and a roof and still die because these weren't managed correctly. Cold alone doesn't kill. It's the combination of persistent heat loss during rest hours that drops core temperature below recovery threshold. The Viking solution: Vikings built semi-subterranean structures using a specific sequence: excavate below frost line, create thermal mass walls, design roof geometry for heat retention, and integrate controlled ventilation. This wasn't one technique. It was a system where each component solved a specific heat loss mechanism. First, ground excavation. Digging 60 to 90 centimeters below surface placed the floor below the frost line. Surrounding earth became thermal mass that stayed at Y-7 degrees Celsius regardless of surface conditions. This eliminated ground conduction and provided baseline temperature stability. Second, wall construction used turf blocks, not timber. Turf is living earth, with roots binding soil. It's dense, heavy, and has high thermal mass. Stacked correctly, turf walls absorbed heat during the day and released it slowly at night. They also regulated moisture. Turf breathes, allowing water vapor to escape without creating condensation. Third, roof angle and material layering. The roof wasn't flat. It was angled to create a heat pocket at the peak, where smoke could escape through a small hole. Birch bark formed the first water barrier. Turf layers on top provided insulation and weight to prevent wind lift. The thickness, often 30 to 40 centimeters, created an R value sufficient to retain heat from a small fire. Fourth, fire placement. The fire wasn't centered. It was positioned so smoke traveled along the ceiling length before exiting. This heated the roof mass and created radiant warmth from above. Heat rises, so ceiling radiant heat compensated for cold air settling at floor level. Why it works. Thermal mass stabilizes temperature swings. Earth at 5 degrees Celsius feels cold to touch, but prevents temperature from dropping below that baseline. This means the shelter never reaches exterior temperatures, even without fire. Turf insulation works, wet or dry, because its mass and density slow heat transfer regardless of moisture content. The roof heat pocket creates stratification. Warm air stays high, cold air stays low, and humans sleep in the middle zone. Why we lost this knowledge? Industrial materials eliminated the need to understand thermal mass. We insulate with fiberglass and foam materials that fail completely when wet. We heat with forced air systems that require sealed envelopes. We build above ground because we have foundations and vapor barriers. Every modern shortcut removed one piece of Viking building intuition until we forgot why their methods worked at all. The Viking shelter wasn't primitive. It was optimized for specific constraints: minimal fuel, wet conditions, no maintenance materials, and months of continuous occupation. Modern construction optimizes for different variables. Neither is better. They solve different problems. The technology wasn't in tools. It was in decisions that compounded over time. Vikings knew which trees had straight grain for splitting. They knew that south-facing slopes provided turf with denser root systems. They understood that certain clay deposits could be mixed with animal hair to create chinking that stayed flexible through freeze-thaw cycles. Material selection was systematic. Birch bark had to be harvested in spring when sap flow made it pliable. Turf couldn't be cut in wet seasons, or it would disintegrate during stacking. Wood for load-bearing posts needed 3 years of drying, or it would twist under roof weight. Every material had an optimal gathering window and preparation sequence. Construction timing was non-negotiable. Foundation excavation happened in early summer when ground thawed. Wall construction finished before autumn rains. Roof installation completed before first snow. Missing any deadline meant partial shelter during winter, which meant high mortality risk. Interior layout followed thermal logic. Sleeping platforms were elevated 40 to 50 centimeters off the ground, placing occupants in the warmest air layer. Storage areas occupied the coldest zones near walls. The fire location determined social organization, everyone oriented toward heat, creating natural gathering patterns that reinforced group cohesion. Maintenance wasn't seasonal. It was continuous. Small gaps in turf walls were packed with moss weekly. Roof drainage channels were cleared after every precipitation. Fire stones were rotated to prevent cracking from thermal stress. This constant attention prevented small failures from cascading into structural compromise. None of this required innovation. It required observation and repetition. A child growing up in this system learned material properties through daily exposure. By adulthood, they could assess a landscape and know exactly what could be built, how long it would take, and whether it would survive winter. The technology was cultural knowledge, embedded in routine action. Living in a semi-subterranean, shelter-changed mental state. Reduced light exposure eliminated circadian variance. Days blurred into continuous, dim awareness. This could have caused seasonal depression, but Viking social structure compensated through forced proximity and routine. The shelter forced cooperation. Space was limited. Privacy didn't exist. Every person's body heat contributed to group survival. Conflict had immediate thermal consequences if someone left. The collective heat budget decreased. This created social pressure toward resolution and cohesion that wasn't moral. It was thermodynamic. Work routines were psychologically protective. Daily tasks maintaining fire, processing food, repairing gear created structure during months of darkness. The repetition wasn't monotonous. It was stabilizing. Modern humans experience winter depression partly because we eliminate routine work while adding isolation. Vikings had the opposite. Mandatory communal labor in confined space. The shelter itself shaped cognition. Low ceilings and earth walls created enclosure that felt protective rather than confining. The constant low-level sensory input, fire sounds, smoke, smell, body warmth prevented the sensory deprivation that triggers psychological deterioration. Modern humans, in isolation experiments, show cognitive decline within weeks. Vikings lived in similar conditions, but maintained stability through environmental consistency. Seasonal transition was ritualized. The first day of sufficient daylight for outdoor work marked psychological reset. The return to normal activity patterns after months of confinement created natural mood elevation that aligned with increased food availability and social reconnection with other settlements. The shelter wasn't just physical protection. It was a psychological container that regulated group dynamics, maintained circadian baseline despite darkness, and provided sensory consistency that prevented mental deterioration. Modern humans separate physical and mental health. Vikings built environments that managed both simultaneously through architectural constraint. We build shelter that makes us weaker. Modern homes are climate-controlled boxes that eliminate thermal stress. We maintain 20 degrees Celsius year-round, removing the need for metabolic adaptation. Our bodies lose the ability to vasoconstrict efficiently, making us vulnerable to even mild cold exposure. We seal buildings completely, then add mechanical ventilation. This requires continuous energy input and fails immediately during power loss. Viking shelters needed no energy beyond fire. They were passively functional. Our dependence on active systems creates fragility that's invisible until the system breaks. We use materials that fail catastrophically when wet. Drywall disintegrates. Fiberglass insulation loses all our value. Oriented strand board swells and delaminates. Viking materials degraded gradually. Turf could get wet and dry repeatedly without losing function. Our high-performance materials are actually high-maintenance materials. We build above ground because we can, not because it's optimal. This requires foundations, vapor barriers, and continuous drainage management. Vikings built partially underground because Earth is free insulation and thermal mass. We added complexity and cost to solve problems that don't exist if you build into the ground. Most significantly, we've eliminated building knowledge from common experience. Ask someone how their house retains heat or manages moisture, and they can't answer. It happens automatically through systems they don't understand. Vikings couldn't outsource this knowledge. Everyone understood shelter mechanics because failure meant direct physical consequences. We're not more advanced. We're more dependent. Viking shelters functioned with zero external inputs and required only knowledge and labor to maintain. Our shelters require supply chains, specialized trades, continuous energy, and replacement parts. Strip away infrastructure, and we can't build shelter that works. That's not progress. That's systemic vulnerability. The principle isn't build like Vikings. It's understand your constraints and optimize within them. Vikings had limited materials, harsh climate, and no external support. They couldn't add complexity. They had to use physics correctly. Modern application means asking different questions. Instead of how do I heat this space, ask how do I retain heat that's already here. Instead of what materials can I buy, ask what materials exist locally that handle moisture. Instead of how do I seal everything, ask where does moisture need to escape. Thermal mass still works. A modern person building shelter in a cold environment should prioritize mass over insulation if materials are limited. A stone or earth wall at 5 degrees Celsius is better than thin insulation that might get wet. The principle applies to emergency preparedness, off-grid building, or anywhere supply chains aren't reliable. Ground coupling still works. Building partially below grade provides free thermal stability. Basements stay cool in summer and warm in winter for the same reason Viking shelters maintained baseline temperature. Modern building codes often prevent this, but the physics hasn't changed. Passive ventilation still works. A well-designed roof with proper heat pocket and exit hole regulates moisture without electricity. This applies to any shelter from tents to cabins. Vikings understood airflow geometry. We've forgotten it because we have fans. The broader lesson is about systemic thinking. Vikings didn't see shelter as a product. They saw it as a machine with thermal inputs, heat loss pathways, and moisture dynamics. Each component affected the others. Modern humans see shelter as a commodity you purchase complete. That mindset fails the moment you need to build, repair, or adapt shelter yourself. Resilient systems require understanding cause and effect at component level. Viking shelters were resilient because every person understood how each piece functioned. That knowledge is transferable. The specific techniques are historical. The thinking process is universal. The Vikings didn't survive because they were tougher. They survived because they built systems that matched their constraints. This channel studies those systems, not the mythology, not the aesthetics, just the methods that worked when failure was fatal. If you think function matters more than comfort, you're in the right place.